In this discussion video, we will do a related rates example involving a spotlight and a skater. This is problem number 10 from worksheet 8, and it says, a skater is skating around the edge of a circular rink that has a radius of 30 feet. A spotlight is located at a point 15 feet from the skating rink and is always pointed directly at the skater. The skater is skating at a constant speed of 5 feet per second. Let the positive x-axis be the line that goes from the center of the rink to the spotlight, and let theta be the angle the skater makes with the positive x-axis measured at the center of the rink. At the point when theta equals pi over 4, A asks, how fast is the distance between the skater and the spotlight changing? Assume the skater is moving away from the spotlight at this instant. And B asks, how fast in radians per second is the spotlight rotating? So first, give yourself 7 minutes to try part A. 4, 3, 2, 1. Pause the video and try part A for about 7 minutes. That may not be enough time to finish the question, but I want you to be thinking about what are the key ideas, how you'd begin. At the very least, I want you to be able to try to draw a picture and then see what you can label and go from there. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 7 minutes. Let's talk about it together. So let's draw a picture. This question mentions there's this circular skating rink. So I'm going to draw a circle and label this as my skating rink. And I'm going to draw a point at the center of the skating rink because this question mentions the center. And then it says that, let's see, there's a spotlight that's located at a point 15 feet from the skating rink. So, okay, there's the spotlight, maybe 15 feet from this edge, or, maybe I could draw here 15 feet from that edge. If I go straight to the skating rink, I'm going to draw the spotlight straight out horizontally to the side. And besides just being kind of nice and, even and symmetric, the reason why I'm doing that is the question mentions that we have this positive x-axis, and that's a line that goes from the center to the spotlight. So let me draw a line from the center to the spotlight. Okay, so this is the direction of the positive x-axis, and maybe if I needed it, I could draw a line going this way, and that would represent my negative x-axis. Alrighty, and let's draw a skater. The problem tells me the skater is skating around the edge of the rink, which means they're not somewhere in the middle. They're not somewhere in the middle, they're at the very edge. So I'm going to draw the skater maybe somewhere over here at the edge. And maybe I'll draw some not so great skates, but imagine they're on skates and they're skating. In part A, okay, let me label them as the skater. Part A says, assume the skater is moving away from the spotlight. So they're traveling this way. The problem also mentions this angle theta. Theta is the angle the skater makes with the positive x-axis. So if I draw a point where the skater is, and I draw that to the center, that angle that makes with this positive x-axis, I'm going to call that angle theta. That's what the problem says. I should make that theta. And I need to assign a variable there because that's changing over time. As the skater moves, this angle is changing. In this case, it's going to get bigger. Alrighty. And at the instant that we care about is when theta is equal to pi over 4. So I've roughly drawn the skater at a place where that angle theta will be pi over 4. Okay, what other things can we label here? Well, the radius of this circle is 30. So that's 30, and this distance from here to here is 30. I also know the distance from the spotlight to the skating rink, which is 15. So spotlight to the skating rink to the very edge is 15. Okay, that means the distance from the center all the way to the spotlight, that is 45. Part A asks something about the distance between the skater and the spotlight. So let me draw a line connecting the skater and the spotlight. Okay, and then that distance is changing over time, so let's assign a variable to it. I might call it z. All right, so, okay, and let me talk about part B a little bit. B is saying how fast is the spotlight rotating. Okay, so where the spotlight is going to be pointing at the skater. So as the skater moves, this angle over here where the spotlight is, this angle is going to be changing. So I'm going to put 2 slashes here. It's not necessarily the same angle as theta. And I'm going to call that alpha. Alpha is this symbol. Alpha is a Greek letter. This is the Greek letter alpha. All right, so we are now ready to write down stuff that we know, rates that we know, and the rate that we want to find. I think it's easier to write down the rate we want to find because in A, that's how fast the distance between the skater and the spotlight is changing. That's dz dt. That's what we want to find in part A. In B, we want to know how fast the spotlight is rotating. That's d alpha dt. And in terms of what we know, the rate we know is the speed of the skater. We know the skater speed is 5 feet per second. Somehow this angle theta is likely going to be relevant. And because the skater is skating around the rink at a constant speed, that means this theta will also be changing at a constant rate. So it would be nice if we could use the skater speed to find, let's use this to find the rate at which theta is changing, d theta dt. So I'm going to leave myself some room, and d theta dt, because theta is changing at a constant rate, so since this rate is constant, I can just compute this as an average rate of change and figure out the change in theta on top and divide that by the change in t. Just figure out how much my angle will change over some amount of time and then divide those, and that'll give me the rate at which my angle is changing. I can only do that because the rate is constant. Okay, so one thing I can think about is, skater's moving around. Why don't I just figure out how much time it takes to go all the way around the circle? If I go all the way around the circle, that'll be 2 pi radians. And then I just need to find, well, how much time? All right, so on the bottom, I just have to figure out, well, how much time does it take for the skater to go all the way around? Okay, so this is where I'm going to use some geometry. Let's figure out the circumference of the circle, which is 2 pi r. So this is 2 times pi, and r is 30. All right, so the circumference is 60 pi, and the units are feet. All right, so to figure out the time that it takes to complete one circle, so the skater is going to complete one circle. To find the time, I just take the distance, which is 60 pi, and divide it by their speed, which is 5. All right, so they complete one circle in 60 pi feet. 60 pi feet, that distance, and you divide it by their speed, 5 feet per second. And when you divide, I'll get 12 pi. And then with the units, the feet per second on the bottom are going to reciprocal. When you divide by a fraction, you reciprocal this and multiply, and then the feet will cancel, and you'll get seconds. Okay, so that is how much time it takes to complete one circle. So that should go on the bottom of my fraction, 12 pi seconds, and this is going to simplify. The pi's will cancel, and I'll get 1 over 6. I will get 1 over 6 radians per second. That's the rate at which theta is changing. Okay, so we are now good in terms of what we know and what we want to find. We need to now set up an equation. Based on my triangle, this is not a right triangle, so I can't use Pythagorean theorem. I can't just say like, oh, tangent of theta is going to be like opposite over adjacent, because it's not a right triangle. And we've seen from lecture that if I care about angles and sides in a triangle and it's not a right triangle, then I try things like law of cosines or law of sines. So that is what we're going to do. Let's do some law of cosines here. Okay, so law of cosines. Let's do a brief review of law of cosines. So law of cosines. This says that if you have a triangle, and I call this angle theta, this A and this B and this C, the law of cosine says that C squared equals A squared plus B squared minus 2AB times the cosine of the angle that's opposite C, cosine of theta. So if we use that from our picture, so I'm going to use it with the Z, the 45, and the 30, and the angle is theta. So law of cosines will give us Z squared equals 30 squared plus 45 squared minus 2 times 30 times 45 times cosine of the angle, cosine of theta. So if we simplify this, we'll get Z squared equals, it turns out 29 at 25 minus 2700 cosine of theta. And so now if we take d dt of both sides, so d dt, we can implicitly differentiate. So on the left, d dt of z squared, on the right of 29 at 25 minus 2700 cosine theta. So on the left, that derivative is going to be 2z times dz dt. On the right, the derivative of 29, 25 is 0 because it's constant. And then derivative of the cosine will be negative sine, so I'll pop out that negative to get positive 2700 sine theta. But then I have to differentiate implicitly and multiply by the derivative of the inside theta to get d theta dt. So that's coming from chain rule. Okay, so now if we start to plug in the stuff that we know, and actually, so I'm trying to find dz dt, let's isolate that. So if I isolate dz dt, I'm going to divide by 2. If I divide by 2, it'll cancel with the 2700 to give me 1350. And then we'll have sine of theta. Remember theta was going to be pi over 4? We figured out d theta dt. D theta dt was this 1 over 6. Okay, so we'll get times 1 over 6. 1 over 6. And on the bottom, we will have z. Well, to find z, I got to plug in my numbers into law of cosines, but just plug in all of the numbers, including the angle. So if we do that, we will get z squared equals, let's see, it was 30 squared plus 45 squared minus 2 times 30 times 45 times cosine of the angle, cosine of pi over 4. If we simplify this, we'll get z squared equals 2925 minus 2700 times cosine of pi over 4, which is 1 over root 2. And if I square root both sides, we'll get z equals the square root of that whole thing. 2925 minus 2700 over square root of 2. And as we've seen before, the z is a length here, so it can't be negative. So I don't worry about it, plus or minus. But that square root is what's going to go on the bottom. So we'll have the square root of 2925 minus 2700 over root 2. All right, so just continuing on the next page where I have some more room, the 6 and the 1350 will cancel, and I'll be left with a 225 here. Okay, sine of pi over 4, this is 1 over root 2. So what I'll end up with is 225 on the top, and there's 1 over root 2, that root 2 I can bring it to the bottom, so I'll get root 2 times this other root. So times 2925 minus 2700 over root 2. And I'm going to leave it like this, just write the units. The units of z, of length, on the top were feet. The units of t on the bottom were seconds. And that is my dz dt. Okay, so we had to use some, let me write that better. We had to use some law of cosines to get this.